Good morning. Today we're going over electron structures and the periodic table. This is our second homework assignment for our chapter on atoms and elements. So let's get started. In the first case, we're looking at how the elements in the periodic table are arranged. We have this really interesting shape, but even though generally speaking mass does increase, they're actually arranged according to the number of protons, which is also known as the atomic number. So this number in the top and the middle is the atomic number, also the number of protons. And the mass generally follows, but it's not exactly. There's a couple spots where it doesn't. So the correct answer would be atomic number. Next, you've got this figure of the periodic table, and we've got an element box that's outlined in green and blue and red. And they want to know, first of all, the one in red, is that likely to be a gas, a liquid, or a solid? And the things on the far right tend to be gases, so that's the right answer there. The element in blue would have the atomic number, let's see. It's the second column. It's this one right here. That's gold. That's 79. And finally, what's going to be chemically similar to the element in green? In part, these elements are organized by reactivity, and everything in the same column has similar reactivity, that is chemically similar. So anything in this second column is going to be similar. The element in green appears to be calcium, so magnesium or strontium or barium, those will all be just fine. There we go. We look at this outline of the periodic table. How do we classify each of these sections? We have this first column is known as the alkali metals, whereas the second one is the alkaline earth metals. This big block in the middle are the transition metals, sometimes also called the transition elements, but everything to the left of this staircase is a metal, so they are transition metals. Speaking of which, that staircase is the line between your metals and your nonmetals. We call those metalloids because they kind of are interesting hybrids between metals and nonmetals. This one up here is hydrogen. This one up here in the top right, that's helium. And they didn't give us tags for these two positions or for this one. But if you got those, then this would be the noble gases. This would be the lanthanide series, and this would be the actinide series. This whole group is also known as the inner transition metals. Next, what elements in addition to lithium make up the alkali metal family? So lithium, also sodium, potassium, rubidium, cesium, and francium. Note that we don't include hydrogen because it's not a metal. So in addition to lithium, then we have sodium, then potassium, then rubidium, cesium, and here we have to spell it C-E-S, and then francium. In addition to fluorine, what makes up the halogen family? So we zoom in so you can see this easier. Fluorine also has chlorine, bromine, iodine, and astatine. I can spell chlorine, clearly looking at my keyboard and not the screen. There we go. Which element is most likely to have chemical properties similar to those of potassium? So if we look at potassium, periodic table, these are ordered in groups, and the groups have similar chemical reactivity. So we're looking for ones that are in the same column or group as potassium. And so the answer would be rubidium. It's in the same column. It's right underneath it, as opposed to strontium, which is in a different column, and scandium, same story. Same with the rest of those. Next, rank them by their ability to conduct electricity. And what we have here, silicon, bromine, and cadmium. So here's silicon, it is a metalloid. Here's bromine, it is a nonmetal. And here's cadmium, which is a metal. And being able to conduct electricity is a property of metals. So cadmium is going to be the best conductor because it's a metal. And bromine is going to be the worst conductor because it is a nonmetal. And silicon is going to be in the middle because it's a metalloid. What is the symbol for americium? It's atomic number 95. It's right here. It's AM. Is it a metal, nonmetal, or a metalloid? It is a metal. This whole group, known as the inner transition metals, actually belongs right in here, right? So 57, 58 would come right after it. Essentially, you split this periodic table here, push the two halves apart, and insert this segment there. So it's still to the left of the metalloids. All of these are metals. Okay, what applies for rubidium? Rubidium is right here. So it is a metal, yes. It is not a nonmetal or a metalloid. It is not a transition element, which would be these ones. It is a main group element. Yes, main group would be these first two columns and these last 6 columns. So it is a main group. It's not a noble gases, those come here. It is an alkali metal because it's the first column. And it is not an alkaline earth metal because that's the second column. Which of these apply for tungsten? All right, let's see. Tungsten, right there, element number 74, symbol W is tungsten. So this is a metal, yes. It is not a nonmetal or a metalloid. It is a transition element, yes, not a main group. It is not a noble gas, nor is it in group 1 or group 2. What about germanium? It's all the way over here. And germanium is a metalloid, not a metal or nonmetal. It is not a transition element, it is a main group element. And it is not in group 8 or 1 or 2. Finally, krypton is on the far right here. That makes it a nonmetal. It is a main group element, and it is a noble gas. In terms of atomic structure, common characteristic of elements in the same group, that is the same column, is the number of electrons in the outermost shell. That's what dictates chemical reactivity. That's why everything in the same column has similar chemical reactivity. Because when two atoms interact with one another, it's the electrons on the surface, that is the electrons on the outermost shell, which actually do the reacting. So if you have the same number of electrons in the same type of outermost shell, then you're going to react in a very similar way. Now, rank elements by atomic radius. Atomic radius increases as we go down the periodic table, but it actually decreases as we go across. Even though we're adding additional electrons, they're adding to the same size shell, and they're actually being held more tightly. So my radius decreases as I go across, increases as I go down. So if we're comparing silicon, aluminum, sulfur, argon, and sodium, silicon, aluminum, sulfur, argon, and sodium, all of these are in the same row. So as we go across, sodium is going to be the biggest, and then as we continue, aluminum, and then silicon, and then sulfur should be the smallest, and then the noble gas there we go, decreases as you go across. Rank them by number of valence electrons. Now for main group elements, it's just the same as the column number. So column 1 has 1 valence electron, column 2 has 2 valence electrons, column 3 has 3, 4, 5, 6, 7, 8 valence electrons. It's just follow the column number. So iodine has 7, xenon has 8. Indium here has 3. Sb, antimony here has 5. And rubidium, all the way at the beginning, has 1. So 1, 3, 5, 7, and 8. Tell the number of valence electrons. Again, you just look at the column number. Here aluminum is in column 3, so it has 3. Group 4A, which is also on this periodic table given as 14. So 1, 2, 3, 4. It's going to have 4. And fluorine, chlorine, bromine, and iodine in this group, they are in group 7, so they have 7. Identify the number of valence electrons in each of the following: lithium, sodium, potassium, rubidium, and cesium. Those are all group 1 elements, so that would be 1 valence electron. Carbon, silicon, germanium, tin, and lead, they're in column 4, so they will have 4 valence electrons. And group 6 would have 6. Which of these has 4 valence electrons? Let's see. S is in group 6, so it would have 6. Mg is in group 2, so it would only have 2. Silicon is in group 4, so it has 4. And both sodium and hydrogen are in group 1, so they each have 1. So silicon is the right answer. Okay, so here they gave us astatine, AT. Now, in order to add electrons to astatine, you pick whether you want to add just 1 or 2, and then you highlight the atom and then click. So now I've given it 2, 4, 6, 8. But if I want to remove them, then I'm going to take this little eraser and hover over the electrons themselves to remove them. I want to put a 1 there so that I have 7 around the astatine. Next, add single electrons or pairs to complete the dot structure for group 4A. It's going to have 4 electrons, and the first 4 are single. So I'm going to add 4. If there were 5, then I'd have to remove one of those singles and put in a pair. I've got carbon. It's in group number, they're calling it 4A. And the electron dot symbol will be carbon. Because it's in group 4, it has 4 dots. And because the first 4 are all single, then it looks just like that, just like element X that I did on the last problem. Oxygen, they're calling that group 6A. So to put 6 around it, I put an O. I'm going to do 1, 2, 3, 4, and then 5 and 6 is going to force 2 of those to pair up. So I have 2 singles and 2 doubles. And it really doesn't matter which side gets the double, which side gets the singles. It doesn't matter at all. Bromine is in, they're calling this group 7A. And with 7 electrons, 2, 4, 6, 7. Lithium is in group 1. It's right there. Now there isn't a lithium, so I'm just going to pick an element. It doesn't matter what it is, and then if I double click on it, it will let me change it to whatever I want it to be. And then I hit enter, so that takes. I'm going to add 1 electron. Next, chlorine, that's in group 7A. And it has 7, just like bromine did. So 2, 4, 6, 7. All right, for radon, radon is a noble gas here at the very bottom. So double click, make that a radon. Hit enter, so that takes, and it has 8. So 2, 4, 6, 8. There we are. Do it for lead. Lead is PB right here, and it has 6. Again, there is no PB, but we can make it lead and give it 2, 4, 6. Oh, can't do it like that, right? 2 of those are going to be unpaired. There we are. I'm sorry, it's in group 4. Excuse me. There we are. Xenon is in group 8, Xe, and 8 means 2, 4, 6, 8. And radium, not to be confused with radon, which we did earlier, but radium, right down here, Ra, and it would have 2. Final question. Hydrogen is placed in group 1 on many periodic tables, right here, even though it's not an alkali metal. On other periodic tables, sometimes they put it over here, even though it's not really a halogen either. So, what really applies for hydrogen? Why can we put it in group 1A and or group 7A? And they give us a hint. Draw the electron dot symbols for H and the 1A and the 7A elements. And so if you do that, and we won't do all of them, we'll just do a couple. We've got hydrogen, it has 1 electron right here. And the electronic configuration is 1s1. If we compare this to lithium, which has 1 electron, and it has the electronic configuration of 1s2, 2s1. And then compare that, let's see, in the meantime we also have helium. It has 2 electrons. These are paired because they're both in the 1s group. And then let's see, fluorine is our first halogen. It has 7. 1, 2, 3, 4, 5, 6, 7. And it has the electronic configuration of 1s2, 2s2, 2p5. All right, so what I want you to see is that hydrogen can belong in group 1 because they both have the same number and type of valence electrons. 1 valence electron. They're both in the s shell. That gives them very similar chemical reactivity, namely that they both easily lose that 1 electron to form 1+ ions. H+ forms very easily, so does Li+. But if you look at the periodic table, look also at fluorine and helium. If we put hydrogen right here, if it gains 1 electron, then it can be like helium, which is the closest noble gas. Just like fluorine, if it gains 1 electron, it would have the same electronic configuration as neon, which is its closest noble gas. So putting it in this column also works because it indicates that if I want to gain electrons instead of lose them, then I'm just like I'm in column 7, which is 1 away from the noble gases. So, all right, if we look at these options here, hydrogen can be placed in group 7A because only 1 electron is needed to fill its outermost shell. And it can be placed in group 1A because it only has 1 electron in its outermost shell. So be very careful with this problem because, see, this justification is true and is also stated here, but this justification only makes sense for this statement, right? Because everything else in 7A also needs only 1 more electron to fill its outermost shell. That's not true of the other elements in group 1A. So hydrogen can be placed in group 7A just like fluorine because both of these need just 1 more electron to fill its shell. If I put 1 in there, it becomes just like helium. And it can be placed in group 1A because they both have only 1 electron in their valence shells. All right, that is it for this homework assignment. Have a great day.